Okay, this is 5.5b college algebra. This is example 4 where A equals this 3 by 3 matrix, and what they're asking us to do is find the inverse of that. So first thing we do is write the augmented matrix. So the augmented matrix would look like that with a straight line, and then we'd put a 3 by 3 identity matrix. Okay, it'd help if I wrote the identity matrix correctly. That's supposed to be a 1. Okay, so what we're trying to do is make this into identity matrix. 1, 1, 1, and these zeros and these zeros. Alright, so that's what we're trying to do here. So, we already have this as a 1, so that's good. So what we're going to try to do is, since we have a 1 there already, we're going to try to change the ones under it into zeros. And that's usually the direction you go. If you have a 1, you try to change the things under it or above it into zeros. So what I'm going to do is I'm going to multiply my first row here by -3, because if I do that, if this becomes a -3, -3 times 1 is -3, plus 3 would make this row a 0. So what I'm going to do is I'm going to just put a -3 out there, and I'm going to leave my top alone, because remember, even though we're multiplying it by -3, it doesn't change. We're trying to change the second row. So this third row will stay the same too. So -3 times 1 is -3, plus this 3 gives me a 0 there now. -3 times 2 is -6, plus 5 is -1. -3 times -1 is +3, plus 3 is 6. -3 times 1 is -3, plus 0 is -3. -3 times 0 is 0, plus 1 is 1. -3 times 0 plus 0 is 0. Okay, now let's change this 2 right here to a 0. And how do I do that? I multiply the top by -2 and then add it to the third row. So again, this row will stay the same. Whoops. And the second row, we're not even doing anything with it, so it's going to stay the same at this point. And we're changing this third row. So what we're going to do is we're going to take -2 times 1 is -2 plus 2. -2 times 2 is -4 plus 4. Got a 2 for 1 there. -2 times -1 is +2 plus 3. -2 times 1 is -2 plus 0. -2 times 0 is 0 plus 0. And -2 times 0 is 0 plus 1 is 1. Alright, so we're getting closer. We've got a 1, a 0, and a 0. Now we need to make this a 1, and this a 0, and this a 1, and we have to go through the whole thing here. And I'm just going to leave the rest of it up to you, because it is stuff that we have done, and we do find an inverse then, and the inverse of that is something crazy like, a 3 by 3. Okay, so there's the inverse. So that's what you'll end up getting as your final numbers here once you change all this all to ones and then these three here to zeros. But rather than having you do that, I'm just going to leave that up to you because I just will go on and on and on and bore you to death, and you should already know how to do this. Alright, if a matrix has an inverse, it is what's called invertible or non-singular. When you cannot get an identity matrix using this Gauss-Jordan method, then there is no inverse. And when this occurs, you will get one of these rows here that you're trying to get to be, looking like this. What you'll do is you'll get one of these rows that has all zeros. And if that's the case, there's no inverse. Okay, so the last section in this lesson is solving systems of equations, and we had just kind of alluded to this a little bit back in, oh gosh, where was it? Was it 5.4? Yeah, it was 5.4 on page 477 at the bottom of the page. We just kind of talked about it, saying that AX equals B. Now we're actually going to do that. Alright, so AX equals B, and if we wanted to solve, let's say we wanted to solve for X. Alright, let's put some numbers up here just to kind of show you. Alright, so the order of events here is if we multiply the A by its inverse, multiply both sides by its inverse, which means this would look like the inverse of 8 is 1/8. Okay, so I multiplied the inverse with A's here, but over here I'm using numbers. Whoops, I probably should put an 8 there since I'm multiplying it by its inverse. Alright, so we're pretending that the 8 is the A. So there's my 8, multiplying it by its inverse. There's my A, I'm multiplying it by its inverse. So inverse of A times A is going to be 1x. Or, I don't know why I put an I there. That doesn't look very 1-ish, does it? That's going to give me 1x equals A to the negative 1b. Okay, so let's use a real number here. When we multiply 1/8 times 8, 1/8 times 24, we get that. Okay, so therefore, x equals A inverse times b, or x equals 3 in this case. So it's just doing algebra here, just solving for x, but you're using the inverse. Normally what you do when you've got things like this is you just divide both sides by 8, which is the same as multiplying both sides by its inverse, which is 1/8. So this is the key right here. This is the key formula that we're going to look at. Alright, so knowing that, let's go ahead and look at example 5. And only one example here because we're not going to go very deep into it in this lesson. So let's go ahead and put number 5 up here. We have negative 2x plus 3y equals 4. Negative 3x plus 4y equals 5. Alright, so what we're going to do is we're going to write an equivalent matrix equation in the form AX equals B. And this is like I had shown you back a few pages. So we're going to make our matrix. Okay. And then we had times, and then we had an X and a Y there. That is what this is. Equals our 4, 5. Okay, so nothing weird. I just took negative 2, 3, 3, 4 into a matrix, put an x and a y since I have two variables. If this were three equations, it'd be x, y, z. Then the answer here I put right there. And that's it. Alright, so first thing we're going to do is we are going to take the inverse of this. So you're going to have to find the inverse. Now back in example 3, we found that the inverse of this, it was 4, -3, 3, -2. Okay, now normally you'll just have to find that. Alright, so now if we take our inverse times our b, we will get our answer. Because see what we've got here? X equals a -1 b. This is from the middle of page 486. So that's what we're going to do. They give us a matrix, we find the inverse, we multiply it by this, and we're done. Okay, because it's ax equals b, and remember what I just did? A to the -1, ax equals a -1 b. Those cancel because the inverse of a number equals 1. The inverse times the number, like 1/8 times 8 equals 1. So x equals a -1 b, which is that right there. Okay, so what they're going to do is they're going to give you a matrix. Your job is to find the inverse of it and then multiply it by the b part, which is this part right there. Okay, the answer. So there's our matrix, and we're going to take that matrix and we're going to multiply it by our b. Now can I multiply that? Well, let's see. 2 by 2 and a 2 by 1. That and that are the same. It's going to give me a 2 by 1 matrix. So it's going to give me a matrix that looks like this here, a 2 by 1. So all I have to do is multiply these two. So to find this point here, this is first row, first column. First row, first column. 4 by 4 is 16 minus 15 is going to be a 1. And this number is row 2, column 1. So 3 times 4 is 12, plus -10 is 2. And that's it. So x equals 1, y equals 2. So what I did is I solved this system of equations. You're used to doing elimination or substitution, but I took the inverse, or I wrote this out in ax equals b form, took the inverse of this, which is right here, multiplied it by b, and was able to find my x and my y. The key thing here, probably the most difficult thing, is they give you this and you have to find the inverse, and then the rest of it's easy. So this to its inverse times this equals your answer right there. Okay, so that's it for 5.5.